So today our focus is going to be on finding the greatest common factor of two numbers by using prime factorization. And so the reason that we use prime factorization, especially when we start having larger numbers, is a lot of times when we're listing out factors, we may forget a factor pair, and then that could end up helping or hindering our ability to find the greatest common factor. So if you recall, the greatest common factor, or GCF, is really the largest divisor that both numbers share. So when I talk about factoring, I'm really talking about dividing out. So it's the largest divisor that both numbers have in common. And so the first ones that we're going to look at is we're going to look at 16 and 20. So the first thing that we need to do is we need to find the prime factorizations for 16 and 20. So when I start by looking at 16, so let me just erase the and so I have room to work. So when I start by looking at 16, I'm going to start with 2 because that's a prime factor. And then I get 8, divide out, I get 2. 8 divided by 2 is going to be 4, divide out, I get 2. 4 divided by 2 is going to be 2. So my prime factorization is going to be 2 to the 5th power, okay? And then when we take a look at 20, the first value that I'm going to use is I'm going to use 5. And so 20 divided by 5 is going to be 10. And then I'm going to divide 10 by 2. I'm sorry, not 10. I get 4. I was thinking of dividing by 2. I'm going to divide this out by, so I get 4. So I'm going to divide 4 divided by 2, and I get 2. And so my prime factorization is going to be 2 to the 2nd power times 5. Okay, and so now what I'm going to do is when I'm looking for the prime factorization, so when I'm looking at the GCF, so for the GCF, what I'm going to do is I need to look for the same numbers in both prime factorizations. Okay, so when I had 16, so 16's prime factorization was 2 to the 5th power. 20's prime factorization was 2 to the 2nd power times 5. And so the values that they have in common are going to be the 2. So my GCF, however, is not going to be 2. So I look for the same numbers in both prime factorizations. And for what I need to do here is I'm looking for the same number of both prime factorizations that have or that can be repeated. And so what I mean by can be repeated is if I look here, I have 2 to the 2nd power. Well, I have 2 to the 2nd power here because if I break this back down into non-exponent form, okay, 1, 2, 3, 4, 5, 2 times 2 times 5. I look for what's the same. So here I have a 2 times a 2, and then I also have a 2 times a 2. Those two numbers are the same in both prime factorizations. So that means my greatest common factor is going to be 2 times 2, which is going to be 4. So when I'm looking for the prime factorization, I have to look for the same numbers in both prime factorizations. And if I have more than one of the same value, so here I had more than 1, 2, I take the most that occurs. So I'm looking for the most numbers that occur that are the same in both prime factorizations. Okay, so let's go ahead and give this another try. So I am going to look at this example. So Keisha is putting together bags of supplies. She puts an equal number of craft sticks. So she's got 42 craft sticks and an equal number of glue bottles in each bag. So she's got 12 glue bottles in each bag. There are none left over. What is the greatest number of bags of supplies that Keisha can make. So the first thing that I'm going to do is I'm going to go ahead, I'm going to find my prime factorizations. So when I look at my prime factorization of 42, I'm going to start with the prime number of 7. 42 divided by 7 is going to be 6. When I pick another value, I'm going to pick 3. 6 divided by 3 is going to be 2. So my prime factorization for 42 is going to be 2 times 3 times 7. Now I'm going to do my prime factorization for 12. So I'm going to start with 3. And then 12 divided by 3 is going to be 4. Pick a prime value of 2. 4 divided by 2 is going to be 2. So my prime factorization for 12 is going to be 2 to the second power times 3. Or if it helps you for the GCF to go ahead and write it out so you can see the values, go ahead and write it out. So then I look for what's the same in both prime factorizations. So here I have a 2 times 3, and here I have a 2 times 3. So these values are the same. So my prime factorization is going to be, so the GCF prime factorization is going to be 2 times 3, which equals 6. So the greatest common factor for 12 and 42 is going to be 6. All right. Now if I do my next one that I'm going to take a look at is going to be, I'm going to jump over into guided practice for those of you that are following along in your book. I'm going to do 18 and 36. Okay, so when I look at 18 and 36, instead of listing all the factor pairs, which 36 has a lot, it has a lot of factor pairs, I'm just going to find the prime factorizations. So when I start with 18, I'm going to do 3, I get 6. 18 divided by 3 is 6. 6, I'm going to do 3 again. 6 divided by 3 is going to be 2. So my prime factorization for 18 is going to be 2 times 3 to the second power. And then my prime factorization for 36 is going to be, I'm going to use 3, I get 12. I'm going to do 3, I get 4, 2, and then 2. So my prime factorization is going to be 2 to the second power times 3 to the second power. So I look for what's the same in both numbers. I'm looking for that common. So I have 3 to the second power is going to be the same. So my greatest common factor, I'm going to have 3 to the second power. And then I have a 2. So I'm going to leave this in exponent form, and I'm just going to look at how many 2's do I have that are the same. Well, here I have 2 2's. Here I have 1 2. So the same in both value is going to be a 2. So my greatest common factor is going to be 2 times 3 to the second power. So 3 to the second power is 9 times 2 is 18. So my GCF is 18. So do not leave it in your prime factorization form. You actually need to tell me what the value is of the prime factorization. So this is going to be 18. All right, if I take a look at 14 and 35, I know some of these you might be able to look at and go, ooh, that's the GCF, but we're practicing that skill of finding it using the greatest common factor. So when we start using larger numbers, you have familiarity with it. So with 14, I'm going to do 7. 14 divided by 7, I get 2. 35, I'm going to do 5. 35 divided by 5 is going to be 7. So for 14, my prime factorization is going to be 2 times 7. For 35, my prime factorization is going to be 5 times 7. The GCF, here I don't have to multiply anything out because I only have one value. The GCF is going to be 7. Okay. If I have 22 and 55, so 22, I'm going to start with 2. 22 divided by 2 is going to be 11. 55, I'm going to start with 5. 55 divided by 5 is going to be 11. So let me write my prime factorization. So 22 is going to be 2 times 11, and then 55 is going to be 5 times 11. So my GCF here is going to be 11. All right, so let's go ahead and take a look at your next problem. 148. So I'm going to start with 100, and I'm going to divide 100 by 5. And 100 divided by 5 is going to be 20. And then I'm going to do 5 again. I get 4. I'm going to do 2. 4 divided by 2 is going to be 2. Okay, start with 48. I'm going to go to a different color here so you can see I'm going to do 3. 48 divided by 3 is going to be 16. Divide that by 2. I get 8. 8 divided by 2, and I get 4. Divided by 2, and I get 2. So I end up with my prime factorization for 100 is going to be 2 to the second power times 5 to the second power. And my prime factorization for 48 is going to be 2 to the fourth power times 3. So I look for what I have in common. And so by looking at the value that I have in common, the greatest common factor that I have in common, I have 2 to the second power, 2 to the fourth power. Again, I have 4 2's here. I have 2 2's here, which means 2 to the second power is my greatest common factor. So my GCF is going to be 4. Practice page, I'd like for you to find the GCF using prime factorization. So do not list out the factors. If you list out the factors, I'll hand it back to you after I take a look at it and say you need to use it with the prime factorization practice. What I'm going to do now is I'm going to do a really quick review of how to find the GCF using the distributed property. So this is something that we looked at in topic 1. And so because we're circling back around to the greatest common factor, we're going to review this skill. So if I have this expression, so if I have 30 added to 66, we need to find the greatest common factor. And so I can use prime factorization to help me find the greatest common factor. And the greatest common factor in this case is going to be 6. So I write the 6 outside of the parentheses because that's my factor. So that's what I'm going to multiply by. And then I'm going to divide everything on the inside by 6. So 30 divided by 6 is going to be 5. And then 66 divided by 6 is going to be 11. And that's all I do. I don't add in the 5 added to 11. This is my factoring out. So I've shown the greatest common factor by using the distributed property. This value over here is going to be my greatest common factor. So if we go ahead and take a look at our next one, the next one that we're going to do is 45 and 27. And again, if you need to do your prime factorizations to find the greatest common factor, do the prime factorizations to find the greatest common factor. So the greatest common factor for 45 and 27 is going to be 9. And so I'm going to factor out the 9, and factoring out really means I'm going to divide both 45 and 27 by 9. So when I do 45 divided by 9, I get 5. 27 divided by 9, I get 3. That's going to be my problem. So I have 45 added to 27, and the factoring out answer is going to be 9 times 5 added to 3. And then the next one that we're going to take a look at is going to be 15 and 36. My greatest common factor for 15 and 36 is going to be 3. So I'm going to factor out the 3, and then I divide. So 15 divided by 3 is going to be 5. 36 divided by 3 is going to be 12. I'm hoping that as you guys are watching this, you're going, oh yes, I remember doing this skill. So I now have my GCF is 3, and so my new expression is going to be 3 times 5 added to 12. So what you guys are going to do at this point in time is you are going to find the greatest common factor using prime factorization on that practice page that I printed. And then when you finish that practice page, you're going to work with a buddy on a distributive property match activity. So the last little bit of this lesson I just showed you, you'll do that in a partner game if there's time today. If there's not time at the end of this lesson, then you guys will work on that tomorrow during